Okay, I almost forgot whilst daylight to do a brief video on the modified electric dipole. That's it being received in VK5 running 5 watts. And I've lowered the system enough to be able to operate it properly. So this point here where this module is, this is where it switches over from coax to a longitudinal wave up my unique transmission line designed especially for the system. You'd have to refer to the How It Works video, so I'm not going to go into everything right now. This is just to show the minor modification. So that's just above ground there at the start of the system. Now this is part of the antenna system, but it's not really the active part of the antenna when it comes to transmit. The active part is between the two toruses. Now I'll try and get this to show. So basically that's what I've done. I've modified it. There's now two torus or tori. So if you refer to the previous video, it's essentially just like a very short dipole. On the previous video it had one torus at the very start of the bottom element, and now it has an additional torus a bit above the start of the top element. So the top torus is a little higher. So if you imagine we've got the 2 points of the dipole that start, one goes up and one goes down. The bottom torus is at the beginning of the part that goes down. The top torus is, a few inches up, the one that goes up before it comes out. And this just slightly adjusts the takeoff angle upward. And in the future I could have a system where that's mechanically operated up and down, and it would literally be a way of adjusting the TOA. So as a refresher as well, the two toruses are operating at potential difference at radio frequency. So there are transients or displacement currents occurring between the two toruses all the time as the sign keeps changing. And so the transients or displacement currents that are traversing between those two toruses or tori are what cause or create the rotating magnetic fields. This is Maxwell's Faraday's laws of induction. And as you can see anyway, monitoring on the SDR there in VK5, that even in its low down operating position, it's working very well. I'll move a little further away, and there's a couple more things I'll have to show, and you'll see, if you can still see where it is, it's actually not very far up that tree at all. That tree goes all the way up there, and that's actually not one of my tall ones. This up here, that's one of my tall ones that has the apex of the phase vertical array held up at. But yeah, so this is actually relatively low I'm trying to get this to show. All the trees in the background make it a bit tough. So this is relatively low in height. So you could literally, this is low enough to be a freestanding vertical sort of thing. Now I'll just grab the 100 microamp passive meter. I've got both the elements extended out, so I'm going to do it without me touching one side because I imbalance things and draw E fields. But I'm going to look at it this way, so if there's any TEM waves that are vertical component, it would drive the meter. It is a passive meter, so what I'll do is approach the antenna's own transmission line. Hopefully you get to see this. There you go. I'm literally nearly resting against the transmission line to get that tickle. So as you can see, it's not the unique line that's doing the radiating. It's actually, as I've explained, the electric dipole effect going on in a very concentrated manner. So although it's occupying a very small area where this is taking place, it's very intense. Those displacement currents transiting between the two toruses are creating very strong fringing effect of the electric field lines, as well as, of course, any changes along those field lines are what cause the rotating magnetic fields that we desire for TEM wave propagation, which is typical radio waves, and we tend to call them H fields, which, you know, whatever. To me, H fields means magnetizable fields, but yeah, rotating magnetic fields nonetheless, just Faraday's laws of induction. Now I'll just jump into the station and show the radio. By the way, it's doing very good on 80 meters. I don't know if you saw my video. I think I did one last night showing 80 meters as well. And at 5 watts, it was detectable in Canada on 40 meters, but the noise was so bad I didn't bother recording it. So you can see we're transmitting here. Sorry about the glare. On 40 meters. It's on an IC705, battery icons there, so you know it can't be any more than 5 watts. And that's 5 watts, as you can see, 50%. What I will do while we're recording, I'm going to drive this down to 10%, which is 1 watt. Let's see. Okay, I'll try and get that to show. It really doesn't want to show, does it? That's at 10%, okay. So that's 1 watt now into VK5. And still making it. Obviously a bit of QSB there taking me out, but there she is. Oh, picked about an S5 there. So 1 watt from a very simple, small system. And now I'll bring it back up to the full 5 watts QRO. It's QRP. It's got a QRO for me lately. This radio can't do any more than 5 because I damaged the 12 volt input, so it has to be run on the battery input. There you go. So that's 5 watts into VK5. So yeah, so I did say I would try and do a daytime video showing the slight modification to the electric dipole. I'll just add a few more points as well. So, you know, I'm experimenting with a number of things in a number of ways. So my E-field antennas, like the most recent one that's on the trailer and the one on the car, with those I've actually put a lot of work into what goes on behind the toruses to really help project the E-fields outwards. Now with this, the home base version, because it had the height advantage, I wanted to see how I could go keeping things as simple as possible. So this doesn't have any of that effort put in that area, but it does have the line, which acts like a feedback loop in itself, because back EMF that does get generated, because this is a high Z system, actually creates the opposing sign that basically draws it back in. Okay, and of course the little module here is a very important part of the system, where it transfers me over from a conventional transmission line to my very odd transmission line system for this particular antenna. So what I'm getting at is I could very easily, well, with effort, modify this type of design to be as elaborate as my E-field antenna, the one that I've done recent videos on, where I'm working harder to project the E-fields outwards at the antenna. And in doing that, this would actually have even further increased efficiency. So I'll just grab the field strength meter again and come in close to the transmission line. Now I'm nearly touching the line. So for anyone to say that it's the line that's getting the signal out there, they would probably need their head shred. Anyway, there you go. 7.3, and thanks for watching. I finally kept my promise, because I often forget. I say I'm going to do something and then I forget. 7.3, Crazy Ham, VK3, VKE.